I have some data here that currently is unstructured. If you were to ask yourself how exactly we would retrieve data from these so-called tables, well, we would retrieve it by reference. I would say go find the cell in B4 or find the list in C4 through C7. But it turns out that if you don't really care about the actual cell references and you're just trying to find a value within a field, there are better ways of organizing this data so that it is easier to retrieve. And so what we're going to do is we're going to turn each of these data sets into a table. And so the way I'm going to do it is I'm going to select everything here. Notice I don't have the word kid selected, and I'm going to hit Control T. You can see that it asks me whether I have headers. In this case, I do. What I'm telling Excel is that the first row here contains the values that I want to use as headers. And that looks great. Let's do the same thing here. Control T, enter. Let's do the same thing here. Control T, enter. Okay, looking good. So what I can do now when it's time to reference the data inside these tables is I can use a special semantic language for accessing this data that is going to make a lot more sense than just using cell references. It makes more sense for me to pull something from the kid table and the name field than it makes for me to reference something as like C4, C5, C6. So when we're inside of a table, if you click on table design, you can actually see what your table is called. Right now, this table is called table 1. I would like to call this table kid. And so let's select it and call it kid. Notice that I'm capitalizing kid. You can choose what conventions to use when you are naming a table. I'm just going to name all of my tables in all caps because it's going to make it easier to remember later when I'm referencing them inside of formulas. So this table here, this is going to be a list. Well, obviously we've got a list of kids here. Each entry in this table is going to be a saw. And so let's just go table design, click here, and that's going to be called saw. And then down here we have site. So let's name this to site. Okay. So the data I have here is I've got 4 kids here. And each of them has an age. Each of them has a maximum size of chainsaw that I will allow them to use. Now down here I've got a list of my saws. And you can see that I've got an index for each saw. I've got the brand, the type, and then I've got the bar length. So, an 18-inch bar, a 25-inch, a 14-inch. The little Makita is just a little battery powered. And then these ones are actually bigger. Now down here I've got 3 sites. You can see each site has an index, a name. Gas chainsaws are allowed here, but they're not allowed here. And then also I've inspected each site and discovered that the trees on the Peninsula Trail reach a maximum diameter of 22 inches, whereas down in these 2 trails, the max diameter is 12 and 13 inches. So you can imagine the type of problem I'm trying to steer us towards here. I have kids that are allowed to use certain types of saws, and then I have a few saws of different types, and then that's going to influence what I can cut down at these various sites. And so, for example, if I want to cut things down at Peninsula Trail, well, that's a 22-inch maximum diameter. I'm going to need my MS391, which is 25 inches, which means I'm going to have to use Reese because he can go up to 20. He can operate a saw up to 26 inches. So, and of course, this is ultimately just a contrived problem to force us to retrieve data from these tables. And so, how do we do this? Well, you'll notice that when we go and reference things inside of a table, they look different. There's no reference to column C. There's no reference to row 4, row 7. Instead, it says table and then in brackets, field name. This is going to be really useful to us because a lot of the time we don't need to go sum the values in C4 through C7. The cell reference of those values is incidental. It's actually not that important. What we really care about is that they relate to a certain field inside of a table. And I mean, I think to me, it's kind of self-evident that kid name is much easier for a human to understand than C4 through C7. Okay. You'll notice also that each table has a unique identifier, right? With the kids, I've created a unique ID for each kid. For the saws, I've just given them an index, and then each site has a unique site ID. That's going to be important for us later. So let's just build a little tool that will help us understand which saws each kid can operate, what sites the kid could be sent to. So I've got a kid, and let's just say that I can select which kid I want. So maybe if I say Kate, then I want to figure out what saw she can use and what sites she can operate in. So I'm going to start by doing a tiny bit of data validation. If I just go to data and click data validation here, it will give me the option to allow certain values in this cell. So I don't know, let's allow a list. What should the list be? Let's just watch and see what happens if I allow these. Reese, Kate, Mark, Ruby. Okay, if I hit OK, and now look, I can click on the drop down and it gives me an option to select from those. So that's pretty good. Notice how data validation looks at this. So in this case, we have kind of a conflict between table structure and cell structure. I would love it if it just said, look at the kid table and the name. In this case, it wants to give an absolute reference of C4 through C7. So that's fine. We're just going to allow that. So here, let's just change the way this looks a little bit. How about I make this accent 6? And I'm going to make it bold. Okay, so I want to pick a kid, and then I want to answer some questions. First, let's do just a little bit of, let's just profile the kid. So let's just say, what's the kid's age? What's the kid's max size? And you know what? I could do one more thing. I could also, if I wanted to, I could add their ID. Let's do that too, because the ID will help us with other things. And so, how do I go and retrieve the ID based on what is selected here? Well, I know that Kate is the third value in this list. How do I get the third ID in this list or the third age in this list? Well, we've got some options here. One way I could do this is I could use XLOOKUP. So let's just demonstrate what that would look like. You're going to see that there are advantages to this and there are disadvantages. So I'll show you two different methods, and you can just decide based on the trade-offs what you want to do. If I'm going to find ID using XLOOKUP, then what I would do is say XLOOKUP, and then I would look up Kate over inside of this array. Watch how Excel looks at it. Kid name. See that? It's so much easier for a human to understand. And then once I've found it, I retrieve the corresponding value from kid ID. So I could do that. And you can almost imagine the criteria that are being run here. Compare this to each of these until we find a true. Once we find a true, then pull the corresponding value from here. Okay, so XLOOKUP works great. Okay, let's just do it for each of these. What about age? So XLOOKUP, we're going to look up Kate, and we're going to look, once again, we're going to look for it here. Do you notice the redundancy? Then we're going to find age right here. Okay. Fine. Looks good. And then max chainsaw that Kate is allowed to operate. XLOOKUP, and we're going to find Kate here, and we're going to look for her here. And then we're going to get the max size from here. Kate's probably graduated to a 26-inch, but we'll leave it at 20. Okay, so what's good about this and what's bad? What's good about it is that there are no in-between functions. I just use this to produce this and this and this. So that's the good part. The bad part is that there's some redundancy inside of the XLOOKUP. I have to go find Kate inside of the kid name every single time during the XLOOKUP. And so actually, you could argue that there's a slightly more efficient way of doing this. How would we solve this using index match? So using index match, is going to require one thing nested inside of another thing. Let's write the nesting and then let's actually think about it a little bit. Kate is the second value in name, but let's just use a match function to prove it. Let's match Kate inside of this array and give it 0 for exact match and see what happens. 2. So the match is simply telling us that this is the second value here. And now that we've got that, we could say, well, get the second value now from somewhere else. Let's go to ID and pull the third thing. So this index match is saying, look in kid ID and retrieve the nth value, n being whatever this match produces. So since the match produces a 2, the index will grab the second thing, right? The match here is just saying 2, and the index of kid ID 2. Well, of course, what is kid ID? It's just this right here. And then if you ask the index to grab the second value from that list, well, it's KH Baird. So we could do that. Now, is that more efficient? No, not really. But watch what happens if we offload this match. Let's take the match and instead let's copy it. And let's just make our match up here instead. Oops. Let's add an equal sign. There it is. Okay, so now that we've got the 2 here, look, we can say index kid ID, and now let's, instead of writing that match 3 times, let's just point to this and lock it. Now we just fill down. Oops. Now we can't. Sorry. We have to change the field inside of the kid table, but other than that, it works. So here, index, and well, here this time, let's actually type kid for the kid table, and then if I hit left bracket, it will show me the fields inside of the kid table. This is another advantage of tables. It's almost as though they're pre-generated named ranges. Imagine going through and creating a bunch of named ranges instead of making a table. You could do that, but the table does it for you. And then, by the way, if you change what's written up top here, it automatically changes inside of all of your cell references, which is just a nightmare when it's being done using named ranges. And so index kid, and I think what I want now is age. So look, I just hit tab, close up the brackets and the parentheses. And what does that index need to pull? It needs to pull this value right here. That would be comma 2. And it works. And then same thing, index, kid, and then opening bracket. And this one is going to be max size. So I start typing max, and there it is, max size, comma 2. Close it up, and there it is. So you can see that XLOOKUP is fully self-contained. Index match ultimately is a smaller function if you're willing to just offload the match part to up here. But this gets at a fundamental aspect of data retrieval that it's kind of important to understand. And that is that once you know the index of your, we'll call it your key, once you know that Kate is the second thing, if you're going to be doing a bunch of retrieval of corresponding values, just getting that 2 in a cell somewhere is going to be really important. Produce a 2, and then just go use an index to find the second thing here, the second thing here, the second thing here, the second thing here. The XLOOKUP has to keep looking at the name in order to retrieve its values. The index match never does, because the match finds it once, gets the second thing, and then uses these 3 index functions to just reference the match over and over again. Okay, so we've got some information about Kate. Now let's continue down and ask ourselves, what saws can this kid operate? All right, well, let's find out. So the way we're going to do this is we are going to start with the max bar size for here, and we're going to use it as a filter here. So let's just explore around this idea a little bit, and then we're going to use a function that's really going to help us. So first of all, if I just looked at the bar sizes in the saw range, let's see, that would be bar. Then it gives me 3 bar sizes. Well, how do I get just the ones that meet certain criteria? Now, if I was trying to like add up certain ones that meet a criteria, then I could do that a certain way. Or if I was trying to, here, let's just run the criteria to get at what I'm talking about. I'm trying to figure out which bars are less than or equal to the bar that Kate can operate. So, as you might imagine, this is going to produce some trues and falses. Now, I could take this whole thing and, multiply it by saw bar. I could do that. And that'll give, either an 18 or a 0. But I actually want the 0 to go away. I just want 18 and 14 to show up. And I could say, well, okay, we could change this into an if statement, and we could say, if this whole thing, then, give me saw bar. But then it will give me, oops. Let's try that again, sorry. So if, yeah, I think we're missing some parentheses here at the end. There we go. Okay, so that'll give me 18 false and 14. But again, I'm trying to filter this. I just want to show the stuff that meets the criteria. So how do we do this? Well, this is a really important concept to understand, because it not only makes up the foundation of data filtering in Excel, but if you're going to go on to use Python, particularly the Pandas data science library, this is a concept that you will hit over and over again. And the idea here is simple. I'm just gonna take 3 saws here, and just for a moment, I'm just gonna paste them over here, just so we can look at them. Here's the idea. The idea is that if you can start with your original data set and then give a list of trues, falses, trues that corresponds to your source list, then what you can do is smash this list through this one, and all that will be left is the stuff that had true next to it. Right? So do you see what's happening? If this is the original data and this is the filter, then this is the output. So notice these two had true next to them, and so they both show up right here. That's the idea. And this is fundamental. This really is like the building block of good data filtering and data analysis. That you have an array of data, an array of logicals, and whatever stuff had true next to it it turns into a smaller filtered list. And so if we know that, then that helps us understand the basis of the function we're about to use here. So here's what we're going to do. We're going to list the brands right here, because again, I want the list of saws. So I'm going to list the 3 saws. Yeah. And then I'm going to list trues and falses. It's going to say true if it's less than or equal to 20, and false if it's not. And then it will filter this list based on the list of trues and falses. So here we go. The function we'll use to do this is called filter. So look, it just has 2 arguments. Well, two primary arguments. First, the array. So we're going to filter the saw brands. Then we need to give it an include array. This is going to be an equally sized array of trues and falses that tells us which of these subbrands to include. So what I could do is just say, well, in this case, it would be, I guess, true, false, true. True, false. Wow, if I can type here. False, semicolon, true. I could do that. Because look, like, this is less than or equal to 20. This isn't. This is. So, true, false, true. I could do that, and you can see that it works. Right? This is producing a filtered list of these brands that meet the criteria of being less than or equal to 20. But of course, what I want actually is not this hand-coded array. I want to produce that array. And so what I will do is say, give me saw bar less than or equal to 20. And it works. Same thing. So here, let's F9 this thing to see exactly how Excel's brain is working. That's the list of brands. That's the list of bars. And then, that's the criteria. So hopefully it doesn't surprise you that when we compare this array of bars to the number 20, it gives us an array of logicals. Well, now we're all set then. Look, here is my array. Here is my include array. And so since this is true, this is going to appear in the final list. Since this is false, this thing's going to get eliminated. Since this thing's true, this one's going to stay. So now we run the filter, and away you go. Those two values, and it puts one in each cell. That's the answer. So the filter function is critical. When you're dealing with tables, and more importantly, just when you're dealing with producing not an aggregation of a bunch of stuff like an average or a sum, but actually a list of outputs, filter is going to be important. Okay, let's go one step further here. And now let's ask ourselves which sites this kid could be sent to clear. So how do we grab that one? Here, let's type it in here. What sites? So first, let's just ask ourselves what the answer is, since this is a very small data set. All we need to do is look at the sites and see if their max diameter is less than or equal to the max diameter that we've given up here. So let's start it with just a filter function, and then let's see if we can extend it a little bit. So filter, and I'm going to start with just the names. And so the question now, I've told Excel what I want the output to be. The question now is, how do I produce some trues and falses that tell me which of these actually get to be included in my final output? Well, the trues and falses will come from these numbers here being compared with this number here. And so let's compare these to less than or equal to 20. Let's close it up and see if it gives us a site name. Before I hit enter, I'm going to just ask myself what I would expect to happen. The threshold is 20, so that would be yes, yes, no, which means I should see Scarlet Oak and Cope Hollow, but not Peninsula Trail. Boom. Okay, good. So we actually could go a little further here. Instead of just getting site name, just for fun, let's actually grab all of these, mostly just to make a point. I'm just trying to demonstrate structure here. Now I am telling Excel, within the site table, give me all of the fields between name and max diam. That's what the colon indicates. So now that means name, gas allowed, max diameter. So give me the rows of all of those where the site max diameter is less than or equal to I8. Now I hit enter, and it gives me everything. The name, gas allowed, max diameter. And so once I have this array of trues and falses, I can tell it whatever records I want from the table. Heck, I could have gone all the way back to ID. But the important thing here is that the filter function requires an array of trues and falses to be used upon some other array to determine what stays and what goes. So that's the basic idea. Tables are really important. If you have the ability to reference things inside of tables and to convert data to tables, it's frequently a good idea to do it. When are tables not a good idea? Well, tables are sometimes not a good idea when you're actually trying to write functions in one place that are dependent upon something in another place. So for example, here, let me just give you an example. What if I'm just gonna paste values here. So that's this right here. Let's make this into a table. And if I wanted to add to this, here, let's do some math that makes absolutely no sense. Here, let's just say weird calc. Okay, notice that the table automatically adds it. That's kind of nice. Here, if I just say, how about their age multiplied by their max size chainsaw? Maybe this is like their destructive ability. I don't know. Look at how the table calculates this. When I hit enter, it's not just going to do it for one, it's going to apply it to everything. So that can be good if that's what you want Excel to do. But here, let's just keep going. Let's just do more. What if instead I said, well, actually this time I want this value to subtract this value. Well, if I do that, now it gets a little confused because it says, well, what do you mean? Do you want this whole field to reference this? Do you want just this one? So we hit enter, and now, well, here, let's just look and see. This subtracts this, this subtracts this. So it looks like it has kind of preserved positional referencing here, but then this one, well, it doesn't know what to do. So you have kind of this weird like table, non-table referencing that's happening here. It's not that you can't ever make it work. It's that it can sometimes get a little strange when the table tries to automate some sort of calculation and you actually want the calculation to just kind of stay unautomated. So just be aware that the table is going to try to tableify anything that you put on it. And you know, there's times when you want that and there's times when you don't. Here, let's just say that we decide to have a new kid and this kid is named Thwarth. Well, look, do you see how I added an entry here? And when I typed down below, the table just picked it up. Tables are greedy. Like they if you put something next to them, they just assume that you want it to be assimilated. And you know, maybe that's true. What's the size of chainsaw that a 1-year-old can operate? Maybe just a little baby 4-inch chainsaw, one of the little toy ones. Okay, so tables are greedy. That can be convenient for you frequently, but just be aware that that's what they do. Okay, I think that's the main stuff I need to say about tables. Thanks.